Hello everyone, welcome to MP201. This is our third class, and today we're going to continue programming this part and talk about mixing lathe and mill ops, some things that we'll need to be aware of, and then we're going to start diving into some of the post output and looking at that. Next couple of classes we've got coming up are going to be dealing with the can cycles. So we're going to be talking about can roughing and finishing. We're going to talk about can threading and canned and non-canned lathe drilling and mill or live tool drilling. So let's continue on with this part. Actually, before we get started, can I just see a quick show of hands, make sure everybody can hear me? I always like to do that at the start. Orvie, thank you. Mike, Tony. Okay, great. I think I'm broadcasting. I'm going to go ahead and put everybody's hands down. Thank you. All right, so where we left off, we were finishing up the inside of this bore. And because of the tool we were using and some clearance issues, we were having it hit on the back side. So if we go back in here, on this turn profile level, we had created some geometry that we were using to cut this. And what we may want to do for something like this, for this particular type of cycle, is have the lead in and the lead out be like a horizontal plunge move. So it just plunges in on the lead in, cuts the piece, comes out. If we're trying to do it that way, then a lot of the times what we need to end up doing is creating geometry. It can get to be a real pain cleaning out some of these bore areas with just having the roughing and finishing tool paths. I know that we've had some internal discussions about trying to make that easier, trying to make it easier to program a tool path that'll actually cut the stock after, you know, the stock that's left over from a drilling operation. How do we get it out of the bottom of the hole, and how do we make it easier to program? But what we're going to do is just create some geometry to let us handle that. So what I'm going to do is just create a line parallel, and we'll say that we want to take, I don't know, 10 thou passes because it's a small boring bar. So we'll lock that value in here. I thought there was a way to easily apply that. And I probably just could have also translated this a number of times. There we go. And we'll get rid of that one. Actually, no, we'll leave that because of the radius. Okay. So now what I'm going to do is actually just sketch a line out on the screen, because I don't really care about having this exact right now. And we can also look here at the angle, kind of adjust it that way. And then I can do trim many. So I used this line here to trim up all these pieces of geometry for me. And now I can use them to drive my tool path. So under my lathe finish that we had started before, I'll just rechain this. I'm going to go into single chain mode. And here I'm just chaining individual lines as the pieces that I want to drive. Then under my finish path, I'm going to look at this over here. Again, if we go and do edit tool and then draw tool, this shows us, you know, the shape of the tool that we're using. So when I set this thing up, right now it's only got, I think, 7 degrees of clearance off the tip, which means we're not going to be able to drive it in very far. You know, I probably should have looked at the design of this tool a little bit and adjusted where the tip is. But again, what we're trying to simulate here is how do we draw a tool from a tool manufacturer. You know, we get it in our catalog, it's got the dimensions, and we want to represent those specific dimensions. So this is what we end up doing. We end up drawing a custom tool. In this case, we've got a custom boring bar. So with that tool, what we're going to do here, we're going to say finish step over 5 thou, number of passes 2. And that way, with my 10 thou step lines, I can actually take 2 passes on each line if I want to. Otherwise, all we're going to do is just say number of passes 1. And it's going to drive each one of these contours with 1 finish pass. Now, when you're setting up these tool paths, one of the things you have to pay attention to is the finish direction. You'll notice right now it's trying to finish on the ID. So what it's really expecting is horizontal geometry. What we want to do is finish like this. Oh, that's on the OD. Let me check and make sure. Yeah, we're left upper combo. And we are finishing kind of on the inner face of the part, which is what this is showing here. Now, the way that the tool actually cuts is going to be controlled by how we chained these chains of geometry. So we are cutting on the face. We'll leave everything else kind of the same here. We're on the right side. Lead in and lead out. You notice we're plunging in on our lead in move, straight in, and then lead out. If we are going to go with a 45-degree move like this, then we need to be really careful that the length of the move doesn't cause our tool to hit the back wall of this bore. So one of the things I'm noticing, it says rapid move violates a tool clearance boundary. And I don't know if that's on the lead in part or the lead out. Maybe it's because our back off isn't big enough. What we're going to do is quit toolpath. Let's go back in here and let's go back to the lead out. And let's set it horizontal. And now let's set it to 15 thousandths because we know that's outside of our material. There. And now as we regen, you'll notice that the collision happens. We made it 1, 2, 3, 4, 5 cuts in, and then it's plunging in to its next cut right here. And we don't have enough clearance on the front of our tool. So that's, you know, that's going to be an issue, and Mastercam is really actually reporting a problem. You know, we've got a situation where this next entry from the retract here to the plunge here is going to cause an issue. And you can see that's what's happening here with the boundaries. So what's happening is as the toolpath is calculating, it takes that tool shape and it, you know, looks at the area between the movements to see if there's a collision there, and there's a collision back on here. We can go ahead and say, yes, we can keep writing this because maybe we didn't draw the tool accurately, but those are the issues that we're experiencing here. There's an area where the back edge of our tool is rubbing up against the wall. So Mastercam is reporting, you know, what's really going to happen inside that bore. So we either need to fix our tool, or we need to come up with a different strategy as to how we're going to cut that. So let's see here. So if we took our insert geometry and rotated it, maybe gave us 15 degrees of clearance instead of 7. Let's see what that does for us. Remember that for our tool, we're using this custom boring bar file. So I'll have to save this. We're going to go and open up this custom boring bar tool. And what I'm going to do here is select Alt X and grab one of those yellow lines so that I can grab the geometry itself and grab its color. And now I'm going to go to my quick mask for colors, and I'm going to left click and then double click on that yellow, so it'll select all of the yellow. And now I'm going to do X form rotate. The point that I want to rotate about is actually going to be the center of this radius, so that I can keep it tangent here. And we're going to rotate it 8 degrees. So that's what I get with the 8 degrees of rotation, so that should give me 15 total. It'd still be nice if I had a little more clearance, wouldn't it? You know, just depending on what we got on the board. So maybe we want to go plus 10. That's 25 degrees of clearance. So that would be, you know, the shape of my boring bar tip. And so I'll select OK. And now what I need to do is get rid of these two lines. They're part of the shank of my bar. And I'm going to trim that line there. I'm going to select Alt X to grab the color of the bar. Let's clear colors. And then I'm going to do trim, break, and we're going to do extend. So what I did was extended a separate line there. And now with my color set to 116, I'm just going to create a line endpoint to fill in the rest of that bar. Trim. Okay, so I cleaned up my boring bar tool, save that. We're going to go back into our part file. And there we go. So what else do we have to adjust here? The clearance. So we're going to go back to the parameters here, go to the tool clearance. Side now is going to be from line, so we'll grab that line there, and it says 25. End clearance angle, we'll grab from line, and it's going to be 30, so that's a little bit better. Width, think from the arc and point. If we go to field definitions, from arc/point, returns to the graphics window, prompts you to select an arc. When done, you're prompted to select a point. This arc and point define the tool's width or height. And what I think this option is for is so that you could grab this arc here and then come down here and grab a point, and it'll calculate that delta distance for you. So we're going to do the same thing for the height. We're going to grab an arc and then a point, and you'll notice that it does indeed stick my circle down there. So once more, draw tool. You can see that our clearance angles are good. And for lead in, see what happens if we go 12 thou with the lead in. So we've still got this issue here just because of the tip of the tool. So 45 won't work, which is what I'm trying right here, the 45 degree entry, 135, measured from 0 over here. So if we go resolution 10 degrees instead of 45, now we can select you know, a non-45 degree position. So maybe I want my lead in here to be 20 degrees off of the 180. Still didn't quite get it. Now, the other thing that we may want to do is use a different lead-in for these ones over here and do a separate toolpath. So we could always do that as well. Keep that in mind. We may want to go in here to the finish, take off that last chain, just delete it, regenerate that, and now we want another lathe finish toolpath. I'm just going to grab that single line right there. Same tool, but now we're going to do 2 passes because it's 10 thou per step is what we were doing. Now we're going to do 2 5/1000ths passes and see if we can get away with some parameters here for our lead in, lead out. So, what's going on here? Anybody want to guess? Wrong side. Yep. So I've either got the chain going to the wrong side, or I've got the compensation direction set in the toolpath incorrectly. So I'm going to hit quit toolpath. I'm going to save the operation, and then that way we can go in here, and you see right here, compensation direction left. So we're going to go right, regen. Looks like it makes the first pass okay, but the second pass lead-in move is contacting here on the back side. So we may want to go back in there again and adjust those. See what happens if we go. Let's feed in at a negative angle. Let's go negative 10 degrees to try and avoid hitting that. Looks like it still hits there. So something that we may end up wanting to do is cutting it the other way. If we end up going back into the geometry, rechain, let's go this way. Now in this case you can see the side that we're compensating to, still the right, which is the incorrect side now. So let's right click, change side. So we can do that right from inside the chain manager. And let's go three passes at 3.5. And now what we can do is for lead in, we're going to do a 10 degree lead in, and then lead out, we're just going to come straight back out. Let's go check and see what we got going on with that weird lead out. Let's go 30 thou, 30 thou on the lead in. That looks better. So insert angle is hitting, not entry. Yeah, very true. You know, again, this is just an example showing, you know, how do we create a custom tool. It's up to you guys, obviously, to pick the right tool geometry for your application. I'm just trying to show you guys some methods that can be used to cut this out on the bottom. You know, I agree with I think Era brought it up first. What about just a flat faced drill? You know, that'd be a great operation too, because then you could just plunge it right to depth. The other thing to do, since we do have a radius on the bottom here, you know, depending on how long and deep our bore is, rather than turning it, maybe we just want to come in on the face and circle mill it, you know, with a live tool. So it really just depends on the application that you want to do. So here we're just looking at, you know, some different different kind of lathe operations. And now that we've gotten the bore mostly done, I think what we're going to do is move on and just look at some of this mill turn work. You know, this the class is mainly focused on lathe post processors, but I did want to spend the first couple of classes talking about making sure that everybody's got a good foundation in setting up the tool paths right. Because the real problem with this is that if you don't set up your tool paths and your tools right, the post processor is never going to be able to give you good output, because that input has to be set right before you're able to go and get good output with that. So let's look at doing some of these C-axis features. We have a milling operation on the outside here. This is going to be at C0. How do I know that's C0? Because if we look at this in the top view of the WCS, which is just system top view, the y-axis is always C0 for our posts. Okay, if you're coming from another post, which is part of the thing that I should not have done when we started out our example earlier, Josh had programmed that using an in-house solutions post, which allows you to do some things that our posts don't. So there were some settings that were incorrect, you know, planes and some other things that we need to go back in and fix if we're going to get that to work with the Generic Fanuc 4X mill post. Okay, so what we're going to do is cut these features on the back side here. So let's get another level. We're going to call this slot and contour at C0. Now, what plane do I need to use if I want to start cutting features on this back side here? And it equals, so we're going to set this to top real quick. Okay, for all C-axis tool paths, if you run a C-axis tool paths from the C-axis menu, those tool paths automatically set the planes for you. Michael's correct in that if we want to do any of the mill tool paths on a lathe, we need to set our tool construction plane to back. Back is C0 for our machines. And one of the important things to note when you're looking at the back plane, let me hit select here. Let's see if I can pull it up. Hold on, let's do this. Now, one of the things that's nice, if you ever just want to go pick your plane visually, you can use this little select button here to go and pick the gnomon off the display. But a lot of times there's a bunch of them in the way. So what I like to do is turn off the display of those views that I don't need. So turn off a bunch of these guys here. And let's just go turn on back. We'll turn on back and top. And now when I do select, you notice that the only view icon kind of that's showing up there is this back view. So I'll hit escape. Back is the view that we want. So top WCS, tool and construction plane back. If we've got our setup like this, we can now use a mill tool path to cut these features. If we don't want to bother with setting our tool and construction plane first, there are some C-axis tool paths. And what the C-axis tool paths are basically mill contour and mill drill toolpaths that have had some of their options predefined and have some kind of stripped down features. They're useful paths because you can just go face and then C-axis and then face drill and cross contour without ever having to worry about setting your tool in construction planes. It does that for you. But there are some limitations to these tool paths. Some of them don't allow Y-axis machining, and in general, I like using them because you don't have to worry about setting the planes, but you're not going to have as much capability as you would with a full mill toolpath. Okay, because all of the regular mill tool paths, at least the 3 and 4 axis paths, are available. You can run a multi-axis path, but you're going to be restricted to 4-axis output only. Now, if I wanted to go and cut features on the front of this part at C180, what would I need to do? What plane would I need to use? Michael says front. Anyone else? Okay. With the Generic Fanuc 4X mill post, let me go pick up, let's see, named views. See if it'll. If you look at the back tool plane, look at the positive direction of the x-axis. You notice how it's reversed from, say, the front view? This is really important because if you want to use planes on a part that uses the Generic Fanuc 4X MT lathe post, you need to make sure that every plane is a rotation of the back, meaning that front won't work because front's x-axis is reversed 180 degrees from where it needs to be. So right will get you on the face of the part. Right is a legal view for the face, this is true. But if you want to do a C-axis toolpath or a Y-axis toolpath, and you want to address something at C 180 degrees, you need to rotate the back plane 180 degrees. So right now, if I go into the view manager, back is kind of the only legal view that we have right now for machining with a mill toolpath. Keep this in mind, this is for mill toolpaths on a lathe. You still have C-axis toolpaths which will automatically set the planes for you, which we can certainly use. But this is important that you know about this. So with the back plane, what I'm going to do is come out of here. We've got our tool and construction plane set to back. And I'm going to go planes, rotate planes. If I select rotate planes and I say rotate about X 180 degrees, this is the correct plane for milling on the front of the part. And you'll notice that the Y-axis is facing down, the X-axis is facing to the left. So that indicates that it is the back view rotated 180 degrees about X. So we're going to say, okay, now, if this view matched the front view, when we clicked OK here, it would automatically have overwritten and said front in that box because it's not going to let you create, it'll let you copy a plane, but if you try to create one that is orthogonal to one of the system views, it usually lets you know that. So in this case, we're going to say C 180. Okay? And I will typically do this on a part before I start programming, if it's practical. You know, if you can, go in and set up your planes beforehand. Again, if you use those C-axis toolpaths, it's not that big a deal. So let's do some regular milling, and then let's see C-axis and see kind of what the differences are. Okay, so here I'm getting ready. I want to do like a cross contour type operation. What I want to do here is get the intersection of these two faces. And if we go in and we look at this in the solids, this is just like an imported body. It's what we refer to as a dumb solid because it doesn't have any info. What I'm going to do is see if we can use solids, find features. We're going to have it find fillets. And we're going to tell it to create operations. And then what I'm going to do is see if it found this is a fillet, and it did. So there it found that fillet. And if I do select over here, it found that fillet. Now, why did I do that? Well, I did it so that I could actually come in here and right click on the fillet and do suppress. And then over here, I'm going to click select, I'm going to find that fillet, and I'm going to do suppress. And what that allows me to do is get the intersections of those solid faces without having to create any temporary geometry. And now I can just create a curve on one edge, create those pieces of geometry, okay? And then what I'm going to do is extend these options, right? So we're going to come in here. Let's see how wide this slot is. Looks like it's almost 375. So we might come in here with you know, a 1/4 inch or a 1/875 end mill. And what I'm going to do, let's go 120, is extend these lines over here. And we'll also extend these ones over here. And then I'll just connect these. Ooh, we want to be in 3D mode for this. Okay, I'll just connect those with the line over there. So now I've got some geometry. I can go back in here and I can unsuppress those fillets on the model. And if I look at that, I've now got geometry that I can use to drive that feature. Now keep in mind, we want to machine on the front first, or I should say at C0, which is the back plane first. So I'm going to come back in here and we'll just grab back, set tool and construction plane. So now what we're going to do, tool paths. We'll do the first one here, C-axis. And what we're going to do is a cross contour. Well, actually, so cross contour is generally made like this for making flats on the part. And we'll see if it'll let us do Y-axis machining. Okay, so we're going to grab this as the cross contour that we're going to machine. So you'll notice this shows in the toolpath interface the type of machining that we're assuming that we're going to do, right? We're machining cross like that. So we need to get need to create a tool here or open one. So we're looking for a bull end mill. And one of the things that we want to do is use something with a tool corner radius. And we may not necessarily remember what that radius is. One of the things that I like to do when the dialog comes up, right click here in corner radius, we can say radius of an arc. And will it let me do this again? Yeah. So what I'm in the middle of selecting a point of geometry to return to the dialog box with. One of the things that's kind of a little trick is that you can actually enter another function. So we can go Analyze Dynamic. I can click on this fillet radius, and that gives me the minimum radius of curvature here, which is 20 thou. So I'm going to copy that. I'm going to hit Escape. Then I'm going to hit Escape one more time, and we're back in the dialog box. So I kind of used two functions to get out of the dialog box, go query the geometry, and then figure out what that fillet radius that I needed is. Okay, so we're going to go back in, select the library tool. I'm going to go edit that tool. It's a 1875 end mill. We're going to give it an not O2, an O20 corner radius. Let's say that this is maybe 0.75. Okay. So 3/16 end mill. We're going to say that there's an O20 rad on there. And, you know, figure out some feeds and speeds. Okay, I'm just leaving the defaults because really what we're focused on here is tool setup, making sure that the NCI is coming out correctly, and then how does it post, right? So here we'll do where comp 2D. We're going to the left. We'll do multiple passes. 10 thou finish pass. Oop. Yeah, we can do keep tool down. All right. So you notice if we go in here, the planes are all grayed out. And if we turn off display relative to WCS, you notice it says cross upper left top 1. These are planes that are created for you because we are doing a C-axis cross contour. So just let it do its work. Don't try to reset these things, otherwise a lot of times they won't work. Turn our coolant on. Now what we need to figure out here is we always make sure we're on the correct axis combo, and in rotary axis control we've got the choice between C-axis and Y-axis. So in this case we're doing a Y-axis operation. Select OK, and if I backplot that, okay, looks pretty good. Let's see if it posts, right? That was our big dilemma. Oh, my tool has H0D0. And it's also tool 64, which isn't going to work at all, right? Because this machine might only have like 12 or, I don't know, 16 tool stations or something like that. So depending on how you have your posts set up, you might have this as tool number even 264. But station number is for a mill turn post. This is going to be the tool station number on your turret. So we can combine the station number and the tool number to output it for your machine depending on how your machine is formatted for mill tools. Let's just say this is tool 4 and it is station 4. And and this is all set up. Good catch, Michael, by the way. So let's set that up. So we're 444. By the way, when you are doing a quote-unquote mill-style toolpath on a lathe, the head number becomes the station number in the post. Okay? Save to library. Okay, that's right. And we all should be good there. Okay, so all the rest of the stuff should be good. Save it and post out. Oh, and let's make sure that we have our correct post here. Oh, it's the right turn. I don't want that. Okay, Generic Fanuc 4X MT lathe post. Okay. So we're getting our turning tool paths. Those are all coming out. And now in 26400, that doesn't seem right. Got that all reset. Let's force a regeneration. There we go. TO404. Okay, so I had it all set up for 264. You notice it was 26400. We're always going to get tool number, offset number. Okay. G19, C0, and we are getting y-axis motion. Okay. So again, C180, we're going to have to create our own plane. All right, I already did that. What I want to do here is just do a couple mill ops. We're not going to worry about programming this thing complete because this isn't really a CNC lathe programming class. If you want to see me do it, I'd be happy to, but I want to kind of start to move on to some of the post-processing stuff. And one of the things that I want to get through here is programming on the front spindle, doing a pick-off, cut-off, seeing how that whole process works, and then finishing up on the back side here. And what I think we'll do on the back side is finish on the back side and then maybe thread this outside just to throw a thread on it as well. Okay, all right, so C180. Now again, if I pick cross contour, you notice my tool plane is back. If I go C-axis, cross contour, oh, you know what I need to do here? Sorry, I need to make my geometry. I haven't done that yet. Okay, so again, I'm going to go into solids, find this fillet, suppress it. All right, create some geometry here. So I'm just using create line endpoint. And go in there and extend those. Okay, so once again, I can take those features and unsuppress them. And now I've got my lathe geometry. So, construction plane and tool plane back. I'm going to go ahead and do cross contour. If I try to do it over here, it's going to try and machine from 0. So what I'll need to do is planes, named views. We're going to grab C180. And now I can do cross contour. I'm going to select that as my chain. Same kind of settings. We're going to do wear here. Multi-passes, I'm going to choose to not keep tool down. Okay. So the tool's going to drop in. You know, do I want to take that whole big thing at one whack? Probably not. So maybe I want to copy that operation. And in the first copy, we're going to go here and say stock to leave on walls. Let's go 20 thou. Stock to leave on floors, 0.1. And under multi-passes, I'm going to turn that off so that it just does one pass. Okay, so now if we look at that, would I want this incredibly large lead in? Probably not. You know, that's probably way too generous. So let's go 1 inch on that. Okay. So now if we go and verify all this stuff, operation failed because meshes have infinite points, huh? That's interesting. I wonder if it doesn't like my lathe tool. Well, that was brilliant, right?